In this lecture, we will discuss bus. Now, already many times I have explained inside the system, we have a processor, memory, and IO devices. Now, all these devices are interconnected through system bus. So, this system bus is a combination of three buses: data bus, address bus, and control bus. Now, here data will hold the data and address bus will carry the address. And now coming to the control bus. Now the here processor in the system, always the processor want to read the data or write the data. For that, read write commands are there. So those two commands are under control bus. Control commands. So those will be carried by the control bus. Now here, if you see, this bus is used to transfer the data from between two units, any two units. So now here the timing information to indicate when the processor and IO devices may place data or receive data from the bus. So even the control bus will now it will take care of all the transfer in between any two devices, mostly processor or IO to memory. Now the timing, it will take care of the timing information between the transfer of data. Now here to transfer the data, there is a bus protocol, is a set of rules govern the behavior of various devices connected to the bus. Now to transfer the data, so this bus is having some protocols. Now here two types of schemes are there. One is a synchronous and another one is a asynchronous. Now we will see the synchronous and asynchronous data transfer in this lecture. Now synchronous bus. Synchronous bus means now this is a sender, or you can say it as a master. Now in the previous last class, what we have seen is which device is having the control to keep the data on the data bus is called the master. So here I am taking it as a sender or master or processor. Now receiver or IO devices or slave device, we can say. Now here the master or processor, it is sending the data and by following one clock. Now here you can see the clock. It is by following this clock. By following the same clock, the receiver also receives the data at the same time. Now if data is kept at this time, then the receiver also receives the data at the same time. So without any delay. So this is called the synchronous. Whenever the sender is sending, at the same time receiver will receive. That is called the synchronous transmission, and this is happening because of the sharing the same clock. Both the devices are sharing the same clock. Now we will see the data transfer. If the processor want to read the data from the IO device, input transfer is nothing but what? Processor is reading, getting the data from the IO devices. Now this is a synchronous, means what? Clock is there and all the devices are following this clock. Now the clock, now at T is, this is T0, T1 and T2. At T0 time, if the clock is placed on the bus, when clock is placed on the bus, now this clock is nothing but what? One of the line of the control bus. Now the data and the command, data is, address is placed on the address bus and the command is nothing but what? If the processor is getting the data from the IO devices, means what? Reading the data. So command is what? Read command is placed on the, one of the control line is what? One of the control, this is a read is a control command. On the control bus, it will place the read operation. Now here, if you see, for clock, it is going high and again it is coming low. With a single line we have mentioned. So if whenever you wanted to represent the single signal information, that time you can represent by using like this, zeros and ones. Now going high means what? Binary 1. Going low means what? Binary 0. Now if you see the address and command here, now here one box type we have shown. This is nothing but what? Bunch of lines together we are representing here. Now for example, if I say address lines are 16 lines are there. Now to represent like this, for single 16 lines, if I wanted to represent, it will be very difficult to draw the diagram and to analyze the diagram. instead of that, all 16 together we can represent by a bus like this. This is called bus. Okay, now here the 16, if I say, for example, address is 16 means what? A0 to A15, total 16. Now for this address, how can I represent? 4 bits together, it is a nibble, and we can indicate it as a binary equivalent BCD value. So here we have to write the hexadecimal number. Now if I say 1423 X, this is my address of this bus. Then how to write this one? Binary equivalent of this equivalent of 1 we have to write 0001 is the equivalent of binary value of the 1, and 10100 is the equivalent binary value of the 4, 2 like that. Now 10 for 3 is what? 0011. Now all these 16 bits we are representing by using like this. So instead of showing single bit like this 0 and 1, we are representing like this, and inside this bus we will write the address. Okay, now this is the representation of address, and also command word we combined here. The command is nothing but what? Read operation. Now after that, now at the time of t naught, clock is, now this is the clock at the when the clock is at t naught, then address is placed. So master is nothing but what? A processor is placing the address on the address bus, and at t1, now the data is read by data is placed on the data bus, and at T2, processor is strobing the data onto the inside the processor input register of the processor. Now, why this delay is required means what? After placing the address, so this address is going to all the interfacing circuits of the IO devices, which now there the interface circuits need to decode the address. Now for decoding, it needs some propagation of some time. That time is nothing but what? T1 minus T0 time. And also now here we are placing the address and also command words. So address is placed on the address bus, command word is placed on the command on the control bus. So both the buses are having some different propagation delay. So destination it will not reach at the same time. For that also we need to provide some delay over here. Now this delay is nothing but a time taken, time is required to decode the address, and also bus skew. Bus skew is nothing but what? Place the data on the data bus at T1. After decoding the address, now data will be placed on the data bus. Now at T2 again, the now at T2 now address is changing here. Now here if you see the crossing lines means what? Address is changing. If there is no change in address means what? This line will continue like this. But if you see here lines are crossing means what? Here address is changing. Now means what? Microprocessor is changed some other address at the time. Now after completing this address line, if this address is removed from the address line, that time at T2 process will strobe this data onto the inside the processor register, inside the processor register. So this is how the data is processor is reading the data from the IO devices. Now if the processor want to send the data to the IO device, now this is the clock. Now at T0, processor is placing the address and also putting the command, that is nothing but what? Write command it is placing, and at the same time processor will place the data. Now at T1, now this address is decoded by the interface, and after that this data is strobed onto the output data output register in the output interface device at T2. This is how the synchronous output operation takes place. Now coming to the asynchronous, this is the synchronous block diagram. We have seen sender is sending the data, receiver is receiving the data at the same time by following the same clocks. Now coming to the now here asynchronous. Here both sender and receiver are not following the same clocks. Different clocks they are following. It is following. Now why? Because already we have seen in the most of the IO devices are electromagnetic devices, and sender processor is nothing but an electronic device. So processor speed is high compared to the IO devices. So thereby, if both the devices need to follow the same clock means what? Processor is supposed to reduce its speed, thereby what? Overall system speed will reduce. So not to happen that, here if the low speed devices are there, that time it will follow the asynchronous. and also which are connect for that it for the asynchronous. Asynchronous means what? Both the devices will not share the same clock. So then how the sender is sending the data means it will place the data on the data bus by adding the start and stop bits. Now if this is my information, for this information at the beginning it is adding 1 0, that is a start bit. At the end it is adding 1 1 that is nothing but a stop bit. Sometimes it will add 1 and sometimes it will add 2 1s also. So two stop bits also it will add depending upon the device speed. If it is a very slow device, that time it will add two one stop bits. Otherwise, it will add only one stop bit. Now, before going to send the data like this, now master, and this is a slave, master will send one signal to the slave that now master is ready for the data transmission. After receiving the signal, sender will also send one acknowledgement signal to the master, and with that data transfer takes place. So sending this master ready signal and also slave ready signal, these two are called the handshaking signals. By sending the by sharing the handshake signal, so data is transferred between master to slave or slave to master, vice versa. Now this is called the asynchronous transmission. Now in this, how the data transfer takes place, now we will see. Now this is for the input operation, like in the synchronous, how we have analyzed the same here also we need to. Now here clock is missing. So whenever input operation means what? Processor is reading the data from the IO device. Processor is getting the data from the IO means what? Read operation is taking place. So it will place the address on the address bus and also read command and read signal on the read command on the command bus or control bus. And now it will take T1 minus T time for the decoding and also bus skew. And after that, a master will place the master ready signal. After placing the master ready signal, uh, no, after now at this time T1 minus T2 time, all the decoders will decode. Now which device is active, that will receive this master ready signal, and after that next clock, that is at T2 time, slave will place the slave ready signal. After receiving the master ready, for that slave also react by sending the slave ready, and along with the slave ready, it will place the data on the data bus. So after placing the data, now for the next time T3, at time T3, now master ready signal will go low means what? Processor will remove the master ready signal. And after removing the master ready signal, now if you see at T4, it will remove the address also. It will remove the address also. Now data is already placed on the data. After removing the address, slave ready is also goes slow, and this data is strobed into the processor. No, nothing but what? This data is read by the processor. This data is strobed into the processor input register. Inside the processor, it is having one input register. So in that, the data will be placed. Now like this, processor is reading the data. Now coming to the output operation. Output operation means what? Processor is sending the data to the IO devices by writing the. Now what is the command word here? Command giving the write signal. Now data address is placed on the address line. At the same time, data is also placed on the data line. Now at T1 minus T0 time is required to decode the address. After decoding, now master will place the master signal. So which device is enabled, that a device will receive the master signal, and immediately it will place the next for the next clock T2, it will place the slave ready signal. After receiving the slave ready, now master ready will go low, and when the master ready is going low means what? Now that for the next now at T3 master ready will go low, and after that at T4 data will be removed and address will be removed. At T5, uh, at T4 only, now that the data is sent to the data is strobed onto the data output register on the now if this is a IO device, output device, then in this output device data output register is there. Now the data will be strobed into this output register.